As your agent gains more MCP tools, a quiet scaling problem creeps in. The traditional approach loads every tool definition into the context upfront and routes every intermediate result back through the model. Connect a dozen MCP servers with a few hundred tools, then fetch a large dataset, and you're burning a fortune in tokens before the agent has done anything useful. Two costs balloon, and it is worth naming them precisely. First, tool definitions. Every tool schema sits in the context on every call. Whether or not it is used, hundreds of tools is tens of thousands of tokens of pure overhead. Second, intermediate data. Fetch a 50,000 row result to filter it down to 3 rows, and all 50,000 rows pass through the context window on the way. The model pays in full to read data it is only going to throw away. Here is the fix, and it is genuinely elegant. Instead of call tool, read result, call tool, read result, you present the MCP tools to the agent as a code API. It can program against. The agent writes a short script, call these tools, join, and filter the results, return just the final answer. And the crucial part, that fetching and crunching runs in a sandbox outside the context window. Look at the code the agent writes. It queries the orders table, gets 50,000 rows, and filters them down to the overdue ones. But all of that happens in the sandbox. The model never sees the 50,000 rows. Only the one-line summary, the count, and the total ever re-enters the model's context. Tool definitions get discovered and called as code, not preloaded as schemas. The result on tool-heavy tasks is up to a 98.7% token reduction. Anthropic's reported 150K down to 2K. With matching cuts to cost and to latency and less context rot because the window stays small. Think about what that means. The model reasons over a clean summary instead of drowning in rows it will never use. But the power here is also the risk, so the warning is non-negotiable. Letting the model write and execute code means that code must run in an isolated sandbox, a microVM or container with no ambient credentials, network egress controls, and resource limits. Combine un-sandboxed code execution with a prompt injection, and you have a critical vulnerability where an injected instruction runs arbitrary code on your infrastructure. Tools like E2B and Model exist precisely to give you that disposable, isolated execution environment. The pattern is excellent, the isolation is mandatory. And notice the deeper idea. This is context engineering in disguise. Keep the window small, do the bulk work elsewhere, return only what matters. It is the same lesson as context engineering, just taken to its most powerful conclusion, and as MCP toolkits keep growing, it is how serious agents stay affordable. Write code, run it in a sandbox, and bring back the answer instead of the haystack.